Two shipping containers, same size, same steel, same corrugated ribs running down the sides, sitting on lots less than a mile apart. One of them looks exactly like what it is. Raw, metal, visible rust bleeding through the paint, the kind of thing your neighbor complains about at the zoning meeting. The other one looks like it belongs in an architecture magazine. Deep matte charcoal finish, smooth shadow lines running across the surface, no rust, no glare, nothing that screams shipping container at all. Same steel box. And the entire difference between those two homes came down to one product that costs less than $200 a bucket. I'm going to show you exactly what that product is, why it works on a molecular level, not just visually, how much it actually costs to cover a full container home, and the honest limitations nobody selling you paint is going to mention. By the end of this video, you'll understand exactly why builders who specialize in container homes treat this one product as close to mandatory, and whether it's the right move for your specific build. Let's get into it. If you're new to this channel, we cover container homes, alternative housing, and honest numbers every single week. No sponsored fluff, no miracle claims. Subscribe now, because the cost breakdown later in this video might change your entire exterior finish budget. First, let's talk about why a raw shipping container looks the way it does, because understanding the problem is the key to understanding why this specific fix works so well. A standard shipping container is built from Corten steel, a weathering steel alloy specifically engineered to develop a stable, protective rust layer on its surface over time rather than corroding all the way through. That's fantastic for a cargo box that spends 15 years getting slammed around on ocean freighters. It's a much harder sell for a family home. The corrugated ribbing running down the container's walls exists purely for structural rigidity. It's what lets a thin sheet of steel resist the twisting and racking forces of being stacked 9 high on a container ship. But that same ribbing is exactly what makes a container read as industrial the moment you look at it. Light hits each rib and each valley at a different angle, creating a repetitive, mechanical shadow pattern that your brain immediately files under warehouse, not home. And the factory paint job on most used containers, usually a thin single-coat marine enamel, chalks, fades, and shows rust bleed at every seam and bolt hole within a few years, which is precisely the visual signal that makes buyers, appraisers, and honestly your own family skeptical the first time they see the shell. Most first-time container builders respond to this problem the expensive way. Full exterior cladding, wood siding, stone veneer, corrugated metal panels installed over the existing corrugated steel, sometimes running $15,000 to $30,000 to fully wrap a container home in a completely different material. That works, but it also buries the one thing that made a container home affordable in the first place, which is the steel shell itself doing double duty as both structure and exterior finish. Smart builders found a different answer, and it's been sitting in the industrial coatings aisle the entire time. The product is an elastomeric roof and wall coating, sometimes called a rubberized membrane coating, the same category of product used to waterproof commercial flat roofs, RV exteriors, and industrial storage tanks. It comes in 5-gallon buckets, typically priced between $140 and $220, depending on the brand and the solar reflectance rating, and it's applied with a thick nap roller or an airless sprayer directly over the existing steel surface after basic prep work. Here's why it does what it does, and this is the part that separates it from just being paint. A standard exterior paint is a thin film, usually 4 to 6 mils thick once dry, essentially a colored skin sitting on top of the corrugation. It follows every rib and every valley exactly, which means the industrial shadow pattern stays exactly as visible as it was before you painted it. You've changed the color. You haven't changed the shape. An elastomeric coating is applied dramatically thicker, typically 20 to 30 mils in a single coat and up to 40 mils across 2 coats, which is roughly 6 to 8 times the film thickness of standard paint. At that thickness, the coating doesn't just sit on the ribs, it partially fills the valleys between them, softening the sharp geometric transitions that make corrugated steel read as industrial in the first place. The surface stays technically corrugated. You can still feel the ribs, but the shadow lines soften into a more architectural, almost board and batten rhythm instead of a harsh mechanical repeat. That single physical difference, film thickness, is the entire reason this product achieves a result that regular exterior paint simply cannot. The second reason it works is elasticity, and this is where the name comes from. Elastomeric coatings are formulated to stretch, typically 200 to 400% elongation before failure, which matters enormously on a steel structure. Container steel expands and contracts significantly with temperature swings. A corrugated panel can move measurably between a cold winter morning and a 100-degree summer afternoon. Standard paint is rigid. It cracks under that repeated movement, which is exactly why factory container paint fails at the seams first. An elastomeric coating flexes with the steel instead of fighting it, which means it doesn't develop the hairline cracking that telegraphs age and lets moisture in behind the film. And the third piece, the one that ties directly back to something we covered in a previous video on passive cooling, is solar reflectance. Most elastomeric coatings marketed for exterior use carry a solar reflectance index well above standard dark paint, often in the range that can drop surface temperatures on a sun-facing wall by 20 to 40 degrees Fahrenheit compared to bare or dark painted steel. That's not just a comfort benefit inside the house. It also reduces the thermal cycling stress on the steel itself, which extends the life of every seam, weld, and fastener on the exterior of your build. Put those three properties together: thick enough to change the shadow geometry, flexible enough to survive steel's thermal movement, and reflective enough to cut heat gain, and you get a single product that solves the industrial look problem, the rust bleed problem, and a meaningful chunk of the thermal problem, all in one application, for a fraction of the cost of full exterior cladding. Now let's walk through what actually applying this looks like, because the process matters as much as the product. Step 1 is surface preparation, and this is the step every rushed DIY job skips and every professional-looking result depends on. Any active rust needs to be mechanically removed, typically with a wire wheel on an angle grinder or media blasting for larger surfaces, down to a stable substrate. Loose or peeling factory paint needs to come off entirely rather than being coated over, because the new coating will only bond as well as whatever it's sitting on top of. Any seams, weld points, or corner joints get treated first with a fabric-reinforced seam tape or a brush-applied detail coat, because these are the points most likely to move and crack under thermal stress. Step 2 is a bonding primer where the manufacturer specifies one, particularly over any area that had active rust, which typically adds another $30 to $60 per container run in material cost, but meaningfully extends the life of the top coat. Step 3 is the coating itself, applied in one heavy coat or two medium coats, depending on manufacturer spec, usually with a 24 to 48 hour cure window between coats. A standard 40-foot high cube container has roughly 900 to 1,000 square feet of combined wall and roof surface area, which at 150 to 250 square feet of coverage per 5-gallon bucket means most single container builds need 3 to 5 buckets to fully coat the exterior, plus 1 to 2 buckets extra if you're also treating the roof for maximum reflectance, since roof application typically wants a slightly heavier film thickness than vertical walls. Let's get into real numbers, because that's why most of you are still here. For a single 40-foot high cube container, walls and roof combined, expect to use 4 to 6 5-gallon buckets at $140 to $220 each, landing your material costs between $560 and $1,320, depending on brand and coverage target. Add primer where needed, seam tape and detail coating for joints, and basic prep supplies, wire wheel discs, tack cloth, painter's tape for window and door openings, and you're looking at another $150 to $300 in incidentals. If you're doing the labor yourself with a roller in a weekend, your total all-in cost for a single container sits realistically between $750 and $1,700. If you hire it out, professional application, including full surface prep, typically runs $3 to $6 per square foot, which on a 900 to 1,000 square foot container puts contracted labor and materials combined at $2,700 to $6,000. For a larger multi-container build, a 3 or 4 container home running 2,500 to 3,500 square feet of combined exterior surface, DIY material costs scale to roughly $2,000 to $4,500, and professional application lands between $7,500 and $21,000, depending on region and container condition going in. Now compare that against the alternative most builders default to: full exterior cladding. Wood, board, and batten siding over furring strips typically runs $8 to $15 per square foot installed. Fiber cement panel siding runs $6 to $12 per square foot. Stone veneer, which we've covered on this channel before as the go-to luxury exterior move for barn-dominiums, runs $25 to $45 per square foot for the real material, or $5 to $12 per square foot for manufactured veneer panels. On that same 900 to 1,000 square foot single container exterior, wood cladding lands between $7,200 and $15,000, and manufactured stone veneer lands between $4,500 and $12,000. The elastomeric coating, even professionally applied, comes in at roughly a third to a half of what any of those cladding options cost, while still delivering the single biggest visual transformation available for the money, because it directly attacks the thing that reads as industrial in the first place, the raw corrugated shadow pattern, rather than covering it up with a completely different material. System. Let me walk you through 3 real builds using this exact approach, because the results genuinely vary depending on how it's used. The first is a single container studio build in rural New Mexico. The owner used a deep charcoal elastomeric coating on the full exterior, walls, and roof in a 2-coat application, and paired it with black framed windows salvaged from a commercial surplus supplier. From 30 feet away, guests consistently assume it's a custom steel-clad architectural build, not a shipping container, because the matte charcoal finish reads as intentional cladding rather than industrial packaging material. Total exterior coating cost for that build came in at $1,450, done entirely DIY over a long weekend. The second is a 2-container build in East Tennessee, where the owner went with a warm off-white coating on the main living container and left the second container, used as a workshop and storage space, in a lighter industrial gray to create intentional contrast between the house volume and the utility volume. This is a design move worth knowing, using coating color strategically to define which parts of a multi-container build are meant to read as the home and which are meant to read as support structures. Combined material cost across both containers ran just under $2,900. The third is a 3-container family home outside Boise, where the builder hired the coating application out professionally alongside a metal roofing contractor already on site for other work, bundling the labor to reduce the mobilization cost. Full exterior coating across all 3 containers, including full rust remediation on one older container that had sat in a salvage yard for years before purchase, ran $11,200 total, still meaningfully under half of what quoted stone veneer pricing came back at for the same square footage. Now, the honest limitations, because I'm not going to stand here and tell you this is a miracle product with no downside. First, surface prep is not optional, and it's the part people try to skip. If you coat over active rust or failing factory paint without removing it first, the new coating will look fantastic for 6 to 18 months and then start to bubble, flake, and fail from underneath, because the bond was never solid to begin with. This is the single most common reason people report disappointment with elastomeric coatings, and it's almost always a prep failure, not a product failure. Second, this coating changes the exterior appearance dramatically, but it does not add meaningful interior insulation value on its own. It reduces heat gain into the steel and improves comfort, but if your container isn't already insulated on the interior with closed-cell spray foam, this product is not a substitute for that insulation package, it's a complement to it. Third, reapplication is real. Most manufacturers rate these coatings for a 10 to 15-year service life under normal exposure, which is genuinely good, but it's not permanent. And in high UV climates like the desert Southwest, you may see the upper end of that range shortened by a few years without a maintenance recoat around the 10-year mark. Fourth, color matters more than people expect. Very dark colors in extremely hot climates absorb more heat despite the elastomeric formulation's reflectance properties. So if you're building in Arizona or South Texas, a lighter color, even a warm grage or off-white rather than a deep charcoal, is going to perform meaningfully better on your cooling load, even though the deep charcoal photograph's better for a video thumbnail. And fifth, some homeowners, associations, and historic district zoning boards have specific exterior finish requirements that don't clearly categorize an elastomeric coated container, which puts you in the same permitting gray zone we've talked about with other alternative structures on this channel. Check with your local planning department before you commit to a color and finish plan. Get any approval in writing, and don't assume it's just paint exempts you from an exterior finish review in a covenant-restricted neighborhood. So who is this actually right for? Anyone building a container home who wants the visual result of custom architectural cladding without the cladding level budget. Anyone in a moderate to hot climate who wants a genuine thermal benefit stacked on top of the aesthetic one. And anyone working with a used container that already has surface rust or a failing factory paint job, because this process fixes that problem as a byproduct of solving the appearance problem. Where you should think twice is if your container has structural rust, actual metal loss rather than surface oxidation, because no coating fixes that, and you need a structural engineer to assess it before you spend $1 on finishes. And if you're in a strict architectural review neighborhood, get your color and finish approved before you buy the buckets, not after. Here's what I want you to leave this video with. The difference between a shipping container that looks like leftover cargo equipment and one that looks like an intentional, custom-designed home very often isn't a difference in budget at all. It's a difference in knowing which specific product changes the shadow geometry that your brain reads as industrial in the first place, and applying it correctly. $200 a bucket is a real number, and for most single container builds, 3 to 5 buckets gets you there. If you're planning a container build, and you're not sure which coating brand or color performs best for your specific climate, drop your state and your container count in the comments right now, and I'll tell you honestly what I'd use in your situation. I read every single comment. If this changed how you're thinking about your exterior finish budget, hit like. It genuinely helps this channel reach more people trying to build smart instead of overspending on the wrong things. And subscribe, because next week we're breaking down the exact prep and application walkthrough, step by step, on a real container, rust remediation included, so you can see the entire process from bare steel to finished shell. See you in the next one.